So on the bench today, we have this Meanwell RT65B switching power supply. This is a plus 5 at 5 amp, plus 12 at 2.8 amp, and minus 12 at half an amp power supply that I managed to break yesterday. Specifically, the negative 12 output is no longer working. There was a really loud bang, flash of light, and I think I can see the failed component inside. I managed to bridge plus 5 in common accidentally. So let's open it up, take a look at what component failed, see if we can determine what it is. This power supply is basically new, and I would like to repair it. Looks like there's and there is. Okay, that's interesting. Well, the pin came out. It's interesting. So it's one of those little plastic rivets where the center pin basically, that pushes down through, expands the ears apart on it, or whatever you want to call them. So, okay, that just lifts right off. Oh, there's a couple of angled catches here. Okay, I see. So there's these two catches here that catch on these pins here that are bent in, but there we have it open. We can see the failed component. It's very obvious there. Let me see if I can get it further apart. Feels like there's two screws up underneath the sticker, so that would become the warranty void. This heat sink looks to be interesting. It'll need these two screws removed, but that won't fully release it. Never opened up a Meanwell supply before, so this is a first for me and quite possibly a first for you. So it does look like I need to release those screws as well. Have I got an X-Acto floating around here? I know I do. It's just not showing up at the moment. Doesn't seem to want to be visible. So there's a Phillips there. I think that's a Phillips. So that is an interesting way to deal with warranty. It certainly is effective, because now any warranty I had is void. I don't honestly know if I had a warranty with this or not. They're not a super expensive power supply, but they're not super cheap. I've had good luck with them. Let's pull that screw out, and I think that will release the PCB, and it does. The large cap is here, and it should be discharged, but I just want to make sure. It looks to be the only large cap. There's a bunch of caps back across over here. They are definitely relying on solder to build up traces to increase current handling capability. I would guess these are opto-isolators. So we've got the line comes in down here. So line comes in down here, and I'm going to guess that is, well, it's marked on here. line, neutral, and earth ground. Okay, so that makes sense. So earth ground is this big ring around here, which gets connected to the sheet metal through that spot there. We've got line and neutral coming in. We've got 3 resistors there. So let's see, we've got a diode bridge sitting here. Is it a bridge or half wave? I'm assuming it's a bridge. God, I honestly don't know now. No, it wouldn't be a bridge. That wouldn't make any sense at this point. Okay, there's a fuse there. Some caps. There is, like I say, 3 224 22K, 22, well, 224, whatever the 3 of those are. Resistors in series there across line and neutral with a fuse here. We've got a spark gap here. So if we get, you know, like a lightning strike and get high voltage passed in, there's a spark gap there to hopefully shunt that away. There's a D5 here. It looks more like a capacitor to me than a diode. It may be like a, I don't know. I'm assuming it's like a diode that I don't know. I can speculate all day long. It doesn't make any sense. So we've got a separation from the switching side to the earth ground. We've got some there. We've got a couple of clearance cuts along there. Primary, where do we switch over to secondary? So there's primary, we're onto the secondary side. I am not a power supply expert by any means, but you know, I think about things like clearance, and as far as I can tell, the clearance here is good. There's a slot kind of underneath the opto isolators. So I guess we've still got our power supply, our primary power side here. Then we make the crossover through this bigger transformer here to the power supply side, where we eventually end up with the regulated power supply voltages. Where's all the heat sink compound coming from? I've certainly got it all over me. Oh, it's on a couple of places. Oh, crud. I don't really want it all over my fingertips. I'm not a fan of it. For flash, I mean, it works fine for what it's designed to do. I will apply fresh when we go to put it back together. Need another wipe. That one's saturated. I finally broke down and bought, there's little sterilization wipes actually if you're getting like shots. They were pretty inexpensive. Got them as part of an Amazon order. They're really useful for exactly the kind of stuff you see happening here. They're just handy to have on hand. Glasses back. Why does that feel so weird? Oh, it's rubbing up against that resistor lead. Okay. So there is obviously the component that was blown up here. It's well fractured. I think I will desolder the leads first, and then we'll remove it. It's labeled L52. It's obviously not an inductor. course, this board layout obviously can have a bunch of different supplies put together on it. You know, in the configuration it is here, like I said, it's the RT65B, I believe. Actually, it's on the, where's it at? It's on here, RT65B. I've got a couple other Meanwell power supplies here. I've ordered a replacement for this, but I've got a couple others here. This one is it just 15 volts, straight 15 volts? Yeah, 15 volts at 3.4 amps. I could possibly find that same component in it. Or not. So which way does this go in so that you can read? It goes in that way. This one was bought for a different project and then wasn't used, and it does have a negative output rail on it. This is +5, +12, and -5. I actually bought this thinking I was going to use it on that retro chip tester project, but ultimately didn't. So I might be able to pull a part out of there temporarily to get this guy back up. So hopefully the boy, that needs to be cleaned bad. And it should work for what we're going to do here. I've got 3 leads to desolder. Felt like those unsoldered just fine. Looks like the front half of the package is just plain falling off. No surprise, we've got a screw here. Obviously to hold it onto the heat sink. It's of course got heatsink compound on it. But what I'm most curious about is if we can retrieve the part number from it. Oh, it's just a 7912. There's nothing magic about that at all. It is just a -5 volt or -12 volt voltage regulator. Sweet. Wow, it's amazing to me that shorting the plus and minus, the +5 to ground, could blow up a 7905, but just being a 7905, I've got plenty of replacements. I will need a mica washer, because that is fully isolated. Well shoot, I think the fix for this is going to be pretty simple. I'll go get myself a 7912 and we'll see if we can repair this supply. So, as we determined in the previous segment, the blown component was a 7912, which is a -12 volt voltage regulator. So there's a couple of things here to mention. The original part is in a completely plastic case, which means it was it didn't require any kind of isolation from the heatsink here it mounts up against. I'm going to assume that was intentional. I think for a 79, I think for a negative voltage regulator, the backside becomes tied to the input rather than ground. Anyhow, because this is a fully isolated plastic part, and all I have are replacement parts that have the big metal tab on the back, I need to make sure to isolate that metal tab from the heatsink here. And I'm going to do that with a sill pad. The sill pad will help transfer heat, and a shoulder washer. And the shoulder washer is really important here because the screw will go through the shoulder washer. I don't know if you can see this. The shoulder washer has a large it's got a shoulder in here. It's got a large outer ring and then a smaller inner ring, and that smaller inner ring will fit through the hole in the middle of the regulator, and that will keep the screw from making any kind of contact to the metal of that tab, but still be able to mount the part. And of course, with the sill pad on the back, we will get complete isolation because of that shoulder washer and the sill pad from the heatsink. Electrically, they will be isolated, which is exactly what we want. Because of the thickness of the shoulder washer, I am going to remove one of the washers, if I can, off of this screw. I may not be able to remove any of the washers. No, it doesn't feel like I can. So hopefully it will be long enough. We'll find out. So let me put this stack back together again. Based on what I'm seeing on the heatsink, I don't think this is going to be long enough to actually catch and thread in, although it might. Did it actually catch? It did. So I need to loosen it back up. The sill pad isn't square behind it, and see if I can get the sill pad to move a bit. Let me loosen it up some more. Okay, that's got the sill pad square behind the part. That nylon shoulder washer is in the proper place. I can put some torque on that. To get good contact. We can go ahead already and just validate that it is electrically isolated. So I should see continuity to the screw, but I should not see it. Figure out a way to do this. You can see what I'm doing. Hopefully you can see this. To the screw, I will have continuity to the heatsink, but to the metal tab, I don't. And that's what we want to see, is we've completely isolated the metal tab of the 7912 from the heatsink. So that's perfect. That's exactly what we wanted to see. I need to solder that part in and trim the leads. I did not expect that to be a 7912. I just did not expect to encounter a switching or a linear voltage regulator inside of a switching power supply. But you know, it makes sense. Those screws we're going to reuse. They are the originals that go in. Put the heatsink compound. With the sill pad, we shouldn't need heatsink compound. My understanding is it transfers heat on its own. I hope I'm correct about that. The -12 draw for the usage of this is not that large. So this is interesting. I'm looking at where they used a sill pad in another spot, and they've used a shoulder washer, and they have used heatsink compound. This is going to draw 1/2 amp. It's rated for 1/2 amp most. In my application, it's going to draw way less than that. It gets regulated down to -5 for 16K DRAMs, and for the negative side of a RS-232. I don't expect it to get warm. I'm going to leave it as is. That may or may not be a good decision. I'm going to have to research whether you should use heatsink compound with sill pads or not. So I'm under the impression you shouldn't, but I stand to be corrected. Oh, I don't have a tip in the soldering pencil, so it's not going to do very much. Let me find an appropriate tip. I've actually ordered a replacement tip. I finally, I think, worn out my favorite tip for just regular kind of soldering. It's a wedge shape. Turns out the one I really like that I've been using forever is slightly concave on the end, and I guess that's why it kind of pushes around a pin and holds on to it so well. It's a specialty tip. I looked around, I couldn't find anybody that had them in stock. They would have to order through JVC. I went ahead and just got a regular tip that's about the same size, which should be fine. I think my head's not too far in the way here. Solder joints look acceptable. Brand new pair of flush cutters. Oh yeah, they're nice and sharp. No struggling like I was with the old ones. I'm going to check for shorts. I don't see any. But it's always wise to check. I heard a capacitor. So that little beep is probably a capacitor charging up. Once capacitor, so while the capacitor is charging, it appears to be a dead short because current's moving, but once it gets charged, it's an open. Well, except for the leakage. So we don't see it this way, but if we reverse the leads, we'll hear it do that. Reverse them again. Now we're going to discharge it and charge it back up at the opposite polarity. And the polarity really is whatever voltage this is using to measure resistance. And we heard the same thing here. If I reverse it, I'm not seeing any shorts. It's mounted. We've checked to make sure the part is truly isolated, which it is. Oh, I put the heatsink compound away early. I didn't want to put it away that early. Shoot. We will have to dig it back out, but first let's clean the compound off of here and we'll lay down fresh. Yeah, that was kind of hard. It built up a ridge, and we really don't want a firm ridge, something hard, creating a gap here. So lots of aluminum oxide coming off, but that's to be expected. So we're just going to go back in this direction. It's got the plastic isolator down below. Hopefully I won't get a big wad of heatsink compound spraying out of here. I rolled the tube a bit with the lid on, which is why I'm afraid it may spew a bit. So a little bit here again. Around the same spot it was before. There's no components on this heat sink on this side, but it is basically creating larger heat sink area by attaching that heat sink to in here. I'm going to go ahead and add some in here as well, even though it's kind of covered by the first little bit we applied. Good, flipping enough. I've always found heatsink compound. That's the problem. I stuck my thumb right in the middle of it. Damn it. Like I said, it gets everywhere. Every time I use this stuff, it just ends up everywhere. It ends up on everything. I really do find it impossible to work with without just making a huge friggin' mess. This is typical. Every time I use heatsink compound, it ends up everywhere on everything. It is kind of infuriating. Trash. Trash. Screwdriver tip out of the way. spend a few minutes with that heatsink compound completely all over me. So this is going to sit back in like so. There was two round-headed. There's one, there's the other on this end over here. Great. Can I get a screwdriver here that'll hold on to it? Yeah, one of those there, and there's one down here. I'm not tightening these up yet. And then there were two flush head up underneath this sticker here, and let's get the sticker kind of peeled up out of the way. Well, that didn't work great. Come on, sit in there. Now I am going to be suspect of this supply because we don't know if we've damaged other stuff, but we will test it here. Shouldn't be using that other tip. It's the wrong tip for these. This tip actually works really well. So we've got the 7912 we put in place. We've got two other transistors in here, which hopefully are fine. They probably are. Heatsink is back in place on two sides. I want to get this screw in here because that's what connects ultimately the chassis to earth coming in. We saw on the other side of the PCB there was that okay, that was the plastic insulator popping out from under it. We saw on the back of the PCB where they had laid out that spot on the PCB to have little ridges of solder, so with pressure it would make good contact down through. That really connects everything there back up. I am going to wash myself off one more time. Get rid of the last little bits of the heatsink compound. Always make such a mess. I don't see any on here. So really, we move on next to testing it. Let's see. I guess I will actually put the top on for safety, which means at the moment this screw comes back out, because that screw is ultimately what keeps the top cover in place. We saw that it drops down like so and then pulls forward. Like so. And we can go ahead and, of course, my big old fat finger slid that back. We can go ahead and capture that there. That is so bizarre back here that that's how they did that. See if I can get this into place. Like so. This might be really exciting, and it might just be a green LED comes on and that's all that happens here. So there is a power LED down in there. It indicates there's power to the supply. I'm going to actually, okay, power LED is on. Supply should be safe to move around. Let me go to volts. It's on volts DC. Hopefully that is readable and not full of glare. Because of the camera mount, it looks like you can read it. Camera mount gets in the way of me seeing the screen. We've got common here. We should find +5 here. 5.08, we should find +12 here. 11.6, and we should find -12 here now. -11.9. So we have repaired this supply. I'm not surprised. Seeing that was a 7912 voltage regulator. So just to recap, it's a Meanwell RT65B. There's a bunch of different RT65 power supplies in the series. The B happens to be the +5, +12, -12 variant. This other one that we had floating around here, is it also a, yeah, RT65A. So this one's an RT65A, and that's +5, +12, and -5, where this one's -12. So there's different variants of the RT65 series. So make sure to get the right one for your application. I've had good luck with these Meanwell supplies so far. I've used a number of them in smaller projects successfully. I don't have anything bad to say about them. The failure of this one was fully my own fault. It is what it is. So I think we'll wrap this up, and I'll see you in a future video.